Hello everyone, welcome to a new video on group theory. Let's go and work on this nice problem that is somehow related to the previous problem. Okay, so the problem says let G be a group, obviously, okay, and let these two elements, little g, little h, be element of the group, and then we define little phi of g, little phi of h, okay, and little phi of gh, as in the previous video. Then we'll show how it is. Then we have to prove that little phi of g composed with little phi of h is actually equal little phi of g and h. Okay, so if you didn't see the previous video, our function little phi of g was a mapping that was going from the group to itself, so for the codomain to domain G to the codomain G, and it was defined as little phi of G of x was equal to gx G inverse for all x in the group. So obviously f of h is defined as little phi of h of x will be equal to hx h inverse, and little phi of gh will be gh x gh inverse. Okay, this is how we define our functions. So we have to prove, sorry, I went too far down. We have to prove the composition of these two functions is equal to this. First thing, remember that little phi of g composed with little phi of h is this inside this. Okay, this is how I see it. So this is this guy here is f of g, little phi of g, excuse me, of little phi of h of x. Okay, so this function is the one inside. This is the mother. Okay, so let's see how this is. It's going to be very easy. It's going to be equal to little phi of g of this guy of, remember we just defined it here, h x h inverse. We forgot to formally start our proof with let G be a group, and we forgot to put our element x in the domain the domain. Okay, so in the group x is an element of G. Okay, so we have this guy, and then this is equal to little phi of g of this one. Okay, so this function is gonna operate a g on the left and a g on the left and a g inverse on the right. Okay, so this is gonna be g h x h inverse g inverse. Now we have to prove that what we just did, which is little phi of g composed with little phi of h, is actually equal to this one. Okay, so and what is this? Is this one here? Is this equal? Let me put a question mark to this gh x gh inverse. Okay, are these two things equal? Well, yes. Okay, yes. Why? Because these two are equal. Okay, the x's are equal. are these two equal? If I prove you that these two are equal, then this equality holds, right? Remember, is equal to GH inverse. I made a video on it by a nice property that I told you that you would use many times. It's called the socks shoes property. Okay, it says for each group, if these two elements are in the group, this equality holds. Okay, for each group. Have that. We didn't specify if the group is abelian, it's commutative, so we know this, but this holds for each group. So we proved that the composition of these two functions is equal to this, and we are done. I hope you enjoyed. I hope I didn't confuse you. Thank you for watching. I'll see you in the next video.